Hello, I'm Justin Smith with the NX Product Marketing Team, and this is NX Tips and Tricks. Today we'll be taking a closer look at the lattice structure tools within design for additive manufacturing. We'll learn how using filter lattice can help to reduce waste, how manufacturing allowance helps to streamline your designs where finishing processes are needed, and how NX will automatically generate stilts for your designs. We'll also cover how to orient body lattices to best fit your applications. Here we have a simple shape with some overhang, which will define our boundary body for the lattice. We will shorten the edge length to increase the number of nodes and add balls and blends to strengthen the nodes themselves. Absolute blends utilize the exact blend radius specified by the user, while relative blends create a blend factor, which is most useful for more organic designs. You can also use fields to apply variable blends across a lattice body. Once this is completed, we can hide the boundary body and inspect the lattice. You'll notice that there are some parts of the lattice that are not connected to anything, and there are also some dangling rods. Filter lattice is perfect for this. We can select the scope of the filter and other criteria, such as angle, length, thickness, ratio, and any dangling rods. Since I just want to remove dangling rods and the free-floating parts of the lattice, I'll just select entire lattice and apply the changes with no additional filters. Now that we've cleaned up the lattice a bit, we'll be adding a coating of material to the lattice after additive manufacturing. So I can add a manufacturing allowance. The coat will be 0.2 millimeters thick, so I can set the offset to negative 0.2 millimeters and apply. I want a slight offset from the build plan. So here, I can utilize stilts, which will integrate perpendicular rods into the lattice body in the specified direction. This can be done for a variety of reasons, such as a better surface finish on the face. Here, they're designed to be snapped off after the printing process. I can use either a cone or a cylinder stilt shape, which will vary depending on your needs. A cone with a diameter of 0.5 millimeters at the build plane will work well here. We now have a lattice with stilts ready for the first prototype to be printed. We are not limited to a graphical lattice creation like you've just been shown. We can also create a body lattice using this hexagonal unit cell to pattern throughout this boundary body. We'll start by using the unit fill application, where I can adjust the orientation of the unit cell, which will be applied across the body itself. You can also set the edge length, which will be uniform across the body lattice. Once we've oriented the unit cell and applied the changes, we can hide the boundary body and inspect the lattice. You can set the unit cell to conform to a particular surface as well. This unit cell can be convergent, implicit, or imported in NX, giving you endless possibilities for your designs. When using unit surface conformal, the unit cell will automatically be oriented perpendicular to the selected unit face. In this demonstration, we created a bitriangle lattice using the lattice command. We then trimmed off dangling rods and disconnected sections using filter lattice. To complete the part, we added a manufacturing allowance and stilts to prepare the lattice structure for being printed. Lastly, we created a body lattice using custom unit cells. Thank you.